This video is going to cover the two-sample test for population mean. You're going to use this when you have two samples and you're comparing a numeric quantity. So in this case, I'm comparing freshmen to seniors and the amount of time that they spend on homework. So this is going to go along with the hypothesis test packet or document that is posted on Schoology. So I want to know if the freshmen and seniors in my class spend a different amount of time on homework. So first thing that we're going to need to do is we're going to need to check our assumptions. First assumption that has to be checked for every single hypothesis test and confidence interval is that you have a random sample. So I'm assuming that, or you all are assuming, that I randomly chose freshmen and seniors. You're going to have a random sample unless you skewed your data somehow or unless you had a poor study design, which is probably not the case. Next assumption that must be met under two-sample test for mean is that the samples are independent. So I chose freshmen and seniors without any relation to each other. And then your sample sizes have to be large. So if we go back to the one sample test, large means at least 30 or doesn't show skewness or outliers. So if we go to Fathom, in grade level I have all 4 grades listed, but I'm really only interested in the freshmen versus seniors. So what I have to do is I have to get that data separately. So I did that here. This is the freshmen versus the seniors and how much time they spent on homework. Totally, together, the two samples have 16 people. So they're definitely not at least both 30. So what we're going to need to do is look at the two samples separately and see if there's any skewness or outliers. You're going to do that by looking at a graph. I need 2 graphs, one for the freshmen and one for the seniors. If I'm smart, I can make myself 2 graphs by putting the grade level on the x-axis, the amount of time spent on homework on the y, and then I'm going to look at 2 box plots. Now, the senior box plot isn't really an issue. It looks fairly symmetric. The freshman box plot, though, has this outlier here. Any dots are outliers. That's an issue. So if this were your data, and you had this small sample size like I do, and an outlier, that would be an issue. If that's the case, you need to talk to either me, Ms. Button, or your mentor about choosing a different test. For the purpose of demonstrating Fathom, we're just going to move on and say that the 2 assumptions were met. Now you want to test. You are testing to compare means. You need your 2 different attributes. One has to be numeric, the other one has to be numeric or categorical. Because grade level is categorical, I'm going to put that in second category, and then I'm going to put homework as the first category. Anything in blue is something that we can change. So I suspect that freshmen and seniors spend a different amount of time on homework, so not equal to is what I want, but I could change it to less than or greater than. Something we may not have talked about is pooled variances. So variance is related to standard deviation. So if I look at the 2 standard deviations, what I want to know is, are they pretty similar or are they different? In this case, they're pretty different, which is why I used unpooled. If you get 2 standard deviations that are pretty similar, or very similar, you can change it to pooled, but otherwise in my case they're different, so I'm going to use unpooled. At the very bottom, I'm going to get my p-value. So my p-value is 0.39. That's greater than 0.05, so I fail to reject the null. That means I do not have enough evidence that freshmen and seniors spend a different amount of time on homework. Normally a hypothesis test is followed up by a confidence interval, which is underestimate. So that's what I would do next. We are estimating the difference in means. Again, we're going to bring the same 2 attributes as we did before. There's not much that you can change here. Again, we're going to use unpooled. Normally we do a 95% confidence interval. If your mentor tells you to change that, you are welcome to. Otherwise, I would use 95%. That's the normal confidence interval. Our confidence interval does freshmen minus seniors. And we get this confidence interval of negative 295 to 701. So this tells me that the difference in the average amount of time that freshmen and seniors spend on homework is somewhere between negative 295 and 701 minutes. Because 0 is in that interval, it means it's possible that they spend the same amount of time on homework. We can't say definitively, but we don't have enough evidence that they spend a different amount of time on homework.